Okay, part B, determine the absolute min value of f on the closed interval. That means I need to use the min-max theorem. So remember the min-max theorem. Let's clear this stuff off here. Remember the min-max theorem. The absolute min of f requires a candidate's test. So I'm going to do a candidate's test right here. Candidate's test. Remember, absolute max of f, absolute min in this case, is always located at a critical or end point of f. Critical point of f is where f prime, not f prime is 0 or f prime is undefined. Grader wants me to see me identify this, so I write that down. F prime of x is 0 when x equals, I need to look at my graph here, x equals 1, x equals 2, 3, 4, 5, 6. So 1, 2, 3, 4, and 6. In many cases, you'll get a point for that. This problem, they graded it a little bit differently, but I still believe strongly that you would have likely have earned a point for writing that. Even though this one kind of says something different, I still think you'd get a point for that. So let's keep going here. First, the grader wants me to identify where f prime is 0. I've done that. F prime is 0. That part's done. Okay. This other part is just trying to help you understand. If there are 3 times, which we have right here, 3 values of x, where f prime is 0, that means there are 5 candidates. The 3 right here, where f prime is 0, plus the 2 endpoints. The grader is going to expect me to eliminate 4 of those 5 candidates. I can use words to do it, or I can use integrals. Okay, this is a problem we haven't really encountered yet this year, but with 5 candidates, that means I'm going to have to do 4 integrals. I don't get to use a calculator, so I'm not sure I want to do 4 integrals. The other way I can do it is I can use words. And in this case, the words are pretty simple. Because if we look at the graph of f prime up here, we note, and they kind of led us to it, because in part A they asked us to find the local min. They asked us to find the relative or local min of A. Sorry, of f. So we can use that information to our advantage here in part B. We can say something like f only has a local min at x equals 6. So right away, we now only have 3 candidates. So the green statement you have to write so the grader can see what you're thinking. F only has a local min at x equals 6. The next statement is more just for you to keep track of your thinking. You don't have to write it. Therefore, wouldn't hurt, f must have absolute min at either x equals 0, the first point, x equals 6, the last point, or x equal 8. So in the grading, they're just wanting to make sure that you did something to think about 0 and 6 we've taken care of both of those here and through these three lines. So far those three lines would be worth about would be worth the 1 point so far. Okay, so again, we started out with 5 candidates. These 3 plus the 2 endpoints. By writing the green statement, we eliminated 2 of the candidates. We eliminated this one, and we eliminated this one. So now we're down to 3 candidates. That means we can do 2 integrals, or we can use words again to eliminate another candidate. Just to demonstrate, I'm going to use words. If you want to use integrals on this problem, you can solve the entire problem only with integrals. You don't have to have any of these words. The only words you would need would be this blue one. The rest you could have just integrals. But anyway, here's the way you do it with words. You would note for, let's see, starting at time equal 6, let's don't do equal to. So going from time equals 6 all the way to time equal 8. So for that time interval, f prime is positive. So f is increasing. So f of 8 cannot be absolute min of f. Because from time equal 6 to time equal f, f prime being positive means the graph of f is going up. So because f is going up, the last point on f can't be the lowest point on f because f was going up. So right there we eliminated this candidate. We are down to 2 candidates. Right there. 2 candidates. We're working on these points. This was a little tough to grade. You can get 1 point if you have the correct answer. If you don't have enough justification, you're going to lose these 2 points. That's what those 2 points are for. So now to justify, I've only got to find out what is the value at time 0, what is the value at time 6. So I still have to do 2 integrals. So I guess this wording here didn't really help me because I already knew the value of f of 8. That value is 4. So that wording really didn't help me. But that's the idea of how to use words. So moving on here. Here's my integrals. I remember that when you integrate f prime, that's going to tell you how much f changes, how different f is between time 0 and time 8. This equation might look a little weird. Let's show where that came from. So that came from the fundamental theorem. What we would have done is this. We would have said the integral from 0 to 8 of f prime must equal f of 8 subtract f of 0. Therefore, when we rearrange to find f of 0, that's like we put the f of 0 over on this side. We get f of 0 plus the integral must equal f of 8. But we're trying to solve for f of 0. So now we subtract the integral to the other side. We get f of 0 is equal to f of 8 subtract the integral from 0 to 8 of f prime. Like that. So that's the equation we're going to use. Back to here. Now we have to have a way of finding the integral of f prime. we've been practicing this recently. This is a graph of f prime. I want to integrate that graph starting here, x equals 0. Oops, that didn't work. Hold on. Okay, I want to integrate this. So I'm integrating f prime starting at x equals 0, so I draw a vertical line right here. Go to x equal 8, draw another vertical line. Now, oh, and I have to integrate to 8 because 8 is where I know the value of f. You have to integrate to a known value because you're comparing a known value of f with an unknown value. You're using the integral to see how different those two values are. I'm integrating f prime. And dx means horizontal axis. So that means this integral's value can be computed by accounting for this area, this area, this area as a negative because this area is below the axis, and this area. So that means I have 2 plus 6 is 8, plus 7 is 15, minus 3 is 12. The value of this integral is 12. That right there is 12. The 2 counts positively, the 6 counts positively, the 3 counts negatively, 7 counts positively. 4 subtract 12 is negative 8. The value of f at time 0, or at x equals 0, is negative 8. Use the exact same logic to find f of 6. You now make your comparison. Between those two, f of 0 is the lowest. So this is just another way to do the integral. You have your conclusion now. The absolute min of f is negative 8. That's 1 point. I would probably have made sure I read the problem one more time, just to make sure I'm not forgetting something. Determine the absolute min of f. Yep, got it. So that problem is worth 3 total points. Only 1 point for the answer. The other 2 points are the required justification. That justification in this example consists of this statement, which eliminates these 2 candidates. Remember, you have to eliminate all the candidates. That statement eliminated those 2 candidates, leaving 3 candidates. I think they should have written one more thing here. I think they should have written what we showed here, why we eliminated these 2 candidates should have been written. And that was this green statement. So I would not feel comfortable without the green. I feel like I have to have that to show the grader, but I totally understand why there's only 3 candidates to worry about. Then we already know the value of f of 8, so nothing to do there. We have to go find the value of f of 6 and the value of f of 0 using integrals. Then we can write our conclusion. So 2 points for the justification, 1 point for the answer.